Hello and welcome to this Vision Systems Design Tech Summit Quick Chat with XIMEA. My name is Chris McClune and I'm the editor-in-chief of Vision Systems Design. Today's presenter is Kevin Toerne, and he is a sales engineer with XIMEA. Kevin's full bio can be found by clicking on his name next to the video. Kevin, I want to thank you for joining me today. Just to get us started, would you introduce yourself and then maybe just provide a bit of a background of XIMEA for those who may not be familiar with the company?
Yeah, of course. Thanks, Chris. Thanks for the opportunity. So yeah, as he mentioned, I'm Kevin Toerne. I'm a sales engineer for XIMEA. My background, my academic background anyway, was in chemistry, but I got involved with instrumentation a long time ago, and it blossomed into a camera career. So here I am. So XIMEA has been making cameras for 20 plus years. Mostly at the beginning anyway, they were doing only OEM style cameras. So they would find a particular project and they would build a camera specific for that project. And it was about, I guess around 10 years ago, they decided they needed to branch out into the world market. And so they started both a German and a American branch, corporations, to start selling out to the world. And that's now both why we have both off the shelf, as well as we're still doing, of course, all this custom stuff for a number of different OEMs. For the most part, we specialize in USB and PCIe cameras. These are all scientific and industrial cameras. We try to stick into the niche of being very small cameras, lightweight, and with fast interfaces, as well, of course, the custom applications.
Okay, so we know a little bit more about XIMEA now and some of the products that it provides. You mentioned a couple times there custom applications, and now we have a better taste of what you do. Is there an example of a custom application, recent or near recent, of that your products have enabled?
Yeah. Yeah, I get asked that sort of question a lot, and it's funny. Sometimes I don't even know what our customers are doing, but in one particular case, for sure, there was it's called a volumetric capture studio. So it's basically when an actor or actress needs to perform, but virtually. So the editors can then go back. They can record the acting, and they can go back and basically fill in an entire environment virtually, and from multiple different angles. And so this project involved, they needed a pretty large volume to be captured so that several actors could be interacting inside of the area, and they needed it to be captured from basically all angles. So that took up a lot of specific requirements, So of course, cinematography, they value high quality imagery and high speed. So that high speed always comes in from each camera. High speed means different things to different people. Of course, video is usually at most 120 frames per second. The more, the better, so that they can edit for whatever frame rate they're going to be native in the final production. But the main thing is you need a lot of cameras all looking in different places inside of this room, and also separated by fairly large distances to the controlling computer. Of course, this is a studio, so you can't have a whole bunch of fans screaming in there, competing with the actors for the sound. So all those computers need to be located somewhere else. You need pretty long cables, and you combine that with all those high data rates. We had kind of in our back pocket, basically, the ability to do what they needed. So we had some 120 plus cameras, I think, all looking at inside this one studio, so we were able to run those high data rates. I think they were recording 100 plus frames per second from each of these cameras and running into another room where the servers were recording and maybe even starting to process some of the data. It's both, as I mentioned, the quiet. You can't have a whole lot of power dissipation, and so hopefully each camera isn't creating a lot of noise because they need fans. But then also they need to be small. You've got so many cameras located in so many different places. Each of those needs to be pretty small to kind of not get in the way of other things being run around in there. So I think, yeah, that volumetric capture was a good example of what we're able to do with multi-camera systems. And I haven't even mentioned yet the interface we used for this was PCI Express. This is sort of one of our niches. There's not a lot of other companies doing it, to at least to the extent that we do, as much as off-the-shelf sort of stuff that we can offer for PCI Express. So yeah, that utilized a lot of our capabilities, and it was a very interesting project. I'm looking forward to seeing the output if we ever get to learn what they were shooting.
Okay, well, I wanted to talk a little bit about that interface. You know, when we talk about interfaces for cameras for the multitude of vision systems that are out there, there are a number of different interfaces. So you mentioned that in your description of the company and the products about PCIe, PCI Express. What are some of the main advantages of PCIe, of the PCIe interface for cameras?
Yeah, for sure. You know, and not to put down any other interface. Of course, we sell USB cameras, and we're probably going to be coming out with higher speed Ethernet interfaces eventually. But for sure, PCIe has a number of advantages, and that's sort of why we kind of latched onto it as one of our little specific interfaces. Well, but first and foremost, PCI Express has raw speed as its one of its biggest advantages. You know, the current generation of PCI Express, Gen 4, has 16 gigabits per lane. And you can have multiple lanes, obviously. So you get an enormous bandwidth just to start with. We have, you know, there's even a lot of sensors out there that we use that can't even take advantage of one of those lanes. And that's why you'll see maybe in our portfolio, a number of our cameras are just 2-lane, but because that's already saturating the sensor. Second, I would say one of the bigger advantages, and one that we really had to use in that previous example application, was that PCI Express is switchable, meaning you can take the input from a number of cameras and input them through a single interface. So basically, that was another big advantage to this volumetric capture studio. So we're able to take and group together 6 to 10, even 12 cameras at once, and put them into a switch, which would then interface to the controlling computer via one cable. So it just simplified the design. It simplified the cabling and the input into the final server. Another big advantage of PCI Express is the low overhead. So basically every PC out there has a PCI Express backbone, you know, talking RAM to processor and vice versa. So a camera that's running on a PCI Express interface goes straight into your motherboard, if you will, and communicates directly with RAM with basically no latency. And so things like USB and Ethernet will typically have, there's kind of another step in between the raw data being ready and sent as a packet until it's available in RAM to actually have something done with it. So in cases where latency is a big deal, PCI Express offers basically the quickest way to interface. You know, first and foremost, that raw speed gets you the data there very quickly. But second, there's basically no overhead. And even so, the CPU doesn't really even have to get involved. And so the CPU could be busy doing something else if you need it to, without worrying about the data coming into the hard drive or the RAM or whatever's going on. And then all of the above, all of that, you can still have pretty long cable interfaces, as again we did with that volumetric capture studio.
Okay, well, we've covered a lot of what is happening at XIMEA right now. Just with your description of the company, the recent application. What can you tell us about what's next? Is there anything in the pipeline that you can talk about?
For sure, yeah. PCI Express obviously is not going anywhere. New generations are being worked on now. We honestly haven't even started taking advantage of Gen 4, and Gen 5 is right around the corner. The bandwidth desire of our customer set seems to be insatiable. So it seems like we can just keep going faster and faster, and there will always be a new desire, a new need for higher and higher and faster frame rates, but also higher resolution. There are a lot of sensors coming out capable of much higher resolution. Sony is coming out with a lot of really good sensors, still able to run fast. So you definitely need that high speed, low latency interface to be able to accept the data from these really high resolution and very fast cameras. All sorts of new evolutions in camera sensor technology are coming down the pipeline. Backside illumination is becoming more and more prevalent. We're taking advantage of all of that. And there's all sorts of custom features that these sensors are able to offer, especially once it's backside. You can almost make the sensor blind front side and put all sorts of interesting whiz-bang gadgets into the sensor. And thus then the camera can take advantage of that. And we'll be right there taking advantage of all of those things.
All right, perfect. Well, thank you again, Kevin, for sitting down with us for this quick chat.
Thanks a lot. Bye-bye.
Just a reminder that today's session will be available here within the Vision Systems Design Tech Summit platform for the next 30 days. So on behalf of the Vision Systems Design Tech Summit and our sponsor, XIMEA, I thank you for joining us today. Have a good one, and we'll see you soon.